everyone, it's Justin again, and welcome to the Miaville Mall. I'm shopping today with a friend, and we found lots of cool stuff at this novelty gifts and games store. I'm buying 3 fidgets, each for the same price, a book of number puzzles for $12, and a shark pillow for $20. My friend's getting the exact same thing. Since the line's long, we're going to check out together. The store charges a $1 bag fee, and since they love puzzles and math at this store, they give a discount on perfect square days, like the 4th or the 9th of every month. Today happens to be the 16th, so we'll get a discount of the square root of $16. Not bad. But how can we figure out our total cost? We'll need our substitution skills and the order of operations for this one. Let's get into it. So, what expression can we write to represent our situation? Pause here while you give it a try. What expression did you come up with? Here's what I wrote. 2 times the quantity 3x plus 12 plus 20 plus 1 minus the square root of 16. What does each part of this expression represent? Well, I'm buying 3 fidgets, and their price is all the same, but I need to ask what it is when we get to the front of the line. So we'll call the price X for now. Since there's 3 of them, we can use 3X to represent the price of the fidgets. Adding in the prices of the book and the pillow makes up the rest of the group, and then we multiply the whole group by 2 because my friend and I are each buying the same things. We add 1 for the bag fee, and then subtract the square root of 16 because a discount will take money off of our total. These are not included in the parentheses because they're only applied once to our overall total. Let's dust off those substitution and evaluation skills with some examples before finding our total cost. Here we've got the expression x squared plus 8 times the quantity negative 3 plus 2x, then divided by 10. What makes this an algebraic expression? That's right, it's a mathematical phrase that uses numbers, variables, and operations. And it doesn't have an equal sign. It's been a minute since we've talked variables. What's a variable again? Right, it's a letter we use to represent an unknown value. In this expression, the variable is x. What are the operations in this expression? I see squaring, addition, multiplication, and division. Now that we've reviewed the parts of the expression, our first example is to evaluate this expression when x equals 4. So, what are we going to do with the 4? Yeah, we'll substitute it for x in the expression. That'll make the expression look like this. Wherever there was an x, there's now a 4. Remember, it's helpful to put parentheses around the substituted value when it's being multiplied by another value, like with 2 times 4. To evaluate the expression, we have to remember to follow the order of operations. We can use the saying gems to help remind us of what the order of operations is. So, what should the first step be? We should evaluate the grouping negative 3 plus 2 times 4 first. But wait, there are 2 operations in the group. So we have to follow the order of operations again, which means we'll evaluate the multiplication first. 2 times 4. Pause here while you continue evaluating the expression until you have one single value. All right, let's go over this to make sure we got every step down. After evaluating the multiplication inside the parentheses, we have 4 squared plus 8 times the quantity negative 3 plus 8 divided by 10. What's next? Yeah, we still have an operation inside the group, so we'll evaluate negative 3 plus 8. That brings us to 4 squared plus 8 times 5 divided by 10. What's the next step? After the group is taken care of, we move on to exponents. In this expression, that's 4 squared. Evaluating that gives us 16 plus 8 times 5 divided by 10. Next up is multiplication and division from left to right. After multiplying 8 times 5 to get 40, and then dividing by 10, we are left with 16 plus 4. Evaluating the addition as our last step brings us to our final answer of 20. Let's try another one. Evaluate w to the power of 3 minus 6 attached to the absolute value of w minus 5, when w equals 3. First, rewrite the expression, substituting the given value for the variable. Your expression should look like this. Where do you think absolute value fits into the order of operations? Well, although taking the absolute value of a number is a bit like an operation, the absolute value bars are also grouping symbols. Just like parentheses, we evaluate anything inside absolute value bars first. Then we take the absolute value of whatever is inside. What's the first step then? That would be evaluating the grouping 3 minus 5 inside those absolute value bars. Now we have 3 to the power of 3 minus 6 attached to the absolute value of negative 2. Another way that absolute value bars are like parentheses is that when a term is attached to an absolute value, it indicates multiplication. But we have to find the absolute value of whatever's on the inside before multiplying. So what's the absolute value of negative 2? Absolute value is a number's distance from 0, no matter the direction. On a number line, negative 2 is 2 units from 0, so the absolute value of negative 2 is 2. We want to make sure that we don't leave out any operations in the expression. So now that we've calculated the absolute value of negative 2, we'll put it in parentheses to remind us to multiply it by 6. Pause the video while you finish evaluating the rest of the expression. Check your work. Remember, exponents represent repeated multiplication, so 3 to the power of 3 is 3 times itself 3 times, making 27, not 3 times 3. Feel free to pause if you'd like some more time to add to or adjust your work in your guided notes. Here's our last example. Evaluate 2 root n plus 3 times the absolute value of n minus 10 when n equals 25. When do you think the square root will be evaluated within the order of operations? Because exponents and roots are related operations, they're actually evaluated in the same step from left to right, similar to multiplication and division, or subtraction and addition. But just like with absolute value, after taking the square root of 25, we want to put parentheses around the number to remind ourselves to multiply by 2. Go ahead and give this a try. Pause while you work. All right, check your work. First, we want to evaluate the grouping 25 minus 10 inside the absolute value bars, and then take the absolute value. 25 minus 10 is 15, but what's the absolute value of 15? Remember, absolute value is always positive because it describes a distance, so it's just 15. Let's make sure to put 15 inside parentheses, though, to remind us to multiply by 3. Now, we have 2 root 25 plus 3 times 15. What's next? That would be the exponents and roots. Here, that's the square root of 25, which is... Yep, 5. We'll want to put that 5 inside parentheses too. Now we have 2 times 5 plus 3 times 15. We evaluate each instance of multiplication from left to right, and then we add 10 plus 45 to give us our final answer of 55. Nice job. All right, the line's finally moving, and I think we're ready to figure out how much the total cost will be. Wait, what are we missing? The cost of each fidget. I figured out that each fidget costs $6, so now we can evaluate the expression when x equals 6. Pause while you work. Okay, after substituting 6 into the expression, we have 2 times the quantity 3 times 6, plus 12, plus 20, plus 1, minus the square root of 16. What do we evaluate first? Exactly, 3 times 6 inside the parentheses. That gives us 18 plus 12 plus 20. We'll keep going inside the parentheses. Adding all those values together gives us 2 times 50 plus 1 minus the square root of 16. Now that the group is taken care of, what's up next? Yeah, the square root of 16. Now we have 2 times 50 plus 1 minus 4. Up next in the order of operations is multiplication. So we'll multiply 2 times 50 to get 100, and then we work our way from left to right, evaluating the subtraction and addition. That gives us a total of $97. Awesome work. Thanks for helping me figure out the total cost. Today, we learned how to substitute values into single variable expressions with absolute values and roots, and how to evaluate those expressions. Be sure to finish the guided notes and then complete practice levels 1 through 3. Until next time, keep questioning, keep calculating, and remember, the order of operations is your ultimate checklist for evaluating expressions. See you next time.
Hey, hey.